Hi everyone, Sami here. Welcome to this new lesson about multihop eBGP. In the previous lesson, we said that unlike IGPs, BGP has the ability to form multihop sessions. But so far, we have seen sessions only between directly connected neighbors. We will talk more about this in a second. The first question to ask is how is eBGP multihop disabled? To answer it, we need first to talk about the time to live field that we can find in the IP header. This was created to prevent a packet to loop forever in the case of a routing loop, for example. Each time the packet goes through a layer 3 device, the device has to decrement this value by 1. And if it reaches 0, the packet must be discarded. In the case of BGP, this field can be used to limit the scope of the packets. Setting a value of 5, for example, it would limit the number of layer 3 devices the packet goes through to 5. If it reaches 0 before reaching the destination pair, that packet will be discarded. In Cisco, the default time to live of all external BGP packets is set to 1. This means that the packet can go only through a single layer 3 device and it has to be the destination pair. Keep in mind that this is only external BGP and internal BGP doesn't have this restriction. Like we always do, let's do a packet capture and confirm this. This is our current topology. I will try to peer between router 1 and router 3. So here we are on router 1. I have router 2 and 3 already configured. I want to peer router 1 and 3 on their loopback interfaces. So let's test reachability. It is working. Let's start configuring BGP on router 1. The neighbor is the physical interface of router 3. Remote AS65003. I won't need to set the update source since I will be connecting on physical interfaces, but I need to disable the connected check. So now let's do the packet capture and see what's happening. Okay, you just got our first messages. So this one is coming from router 3. And here is the response from router 1. We can see that immediately router 2 is responding with an ICMP error saying that the time to live has been exceeded. Let's see the time to live of the packet sent from router 1. So it should be here in the layer 3 header. Time to live. Here it is. It has a value of 1. So when router 1 sends the packet to router 3, when it gets to router 2, the time to live will be decreased and it will reach 0. When this happens, router 2 has to discard the packet and respond with the ICMP error. If we look at router 3's packets, we can see that they have a time to live of 63. This is because Juniper routers have a default value for TTL of 64 for eBGP multi-hop sessions. So it starts here with a value of 64. When it reaches router 2, the value will be decreased by 1, becoming 63. And that's when we have captured it in this link. Let's get back to the command line and change the TTL for router 1. So here at router 1, to change the time to live value, it's eBGP multi-hop. And here I set the time to live value. Let's set it for at 2, for example. Let's go at the end of this capture. Let's wait for a new message. Okay, here they come. So we have now here from router 1, let's see, the time to live is actually 2. This means that the packet exits router 1 with a value of 2. When it reaches router 2, it will decrease the TTL to 1 and it will send it to router 3, which will receive it. We can see that the BGP session has come up here. We can change again the TTL to another value. Let's say, for example, 180. Let's do a clear IP BGP everything just to make them talk again. Oh, sorry, do. Oh, let's get at the end of the packet capture. Let's see a message here from router 1. We can see that the time to live has changed to 180. To verify the time to live with a neighbor, we can do show IP BGP neighbor, the IP address of the neighbor. We'll do include, we'll do hops away. So here we can see external BGP neighbor may be up to 180 hops away. We have just seen that the configuration for BGP multihop is to specify a neighbor and then add the keyword eBGP multihop and the value of the time to live to use for the packets destined to this neighbor. And to verify the TTL used for a neighbor, we can do the show IP BGP neighbor. Since the output of this command is very long, we can include a filter for the hops away. One last important thing is that the eBGP multihop command implicitly adds the disable connected check. So when you issue the eBGP multihop, the disabled connected check is automatically added. Now that we understand how to configure eBGP multihop, let's talk about TTL-security. So what is TTL-security? TTL-security is a mean to protect the control plane against denial of service attacks. For example, a TCP SYN attack. Those kind of attacks are designed to overwhelm the CPU of the router by generating a large amount of BGP packets. And all those packets need to be processed by the CPU, which will cause a huge strain. TTL-security is restricted for eBGP only. You can't use it with internal BGP. Also, TTL-security is mutually exclusive with eBGP multihop. You can't have both configurations at the same time. Let's see how TTL-security works. When TTL-security is enabled, the local BGP packets always are sent with a value of 255, which is the maximum value possible for the time to live field. Then we need to specify the maximum numbers of hops allowed for a neighbor. This way we define a scope. BGP messages from speakers that are outside of this scope will be immediately discarded without being processed. Incoming BGP packets must have a minimum TTL value that is superior to 255 minus the number of hops defined. This way we can guarantee that the BGP packets that will be processed were generated within the scope we have defined. Here we are back at the packet capture. Let's try to configure TTL-security. Let's first check the current configuration. So it's chevron section BGP. Here we can see that eBGP multihop is still here. We said that TTL-security is mutually exclusive with eBGP multihop, but let's try to configure them both at the same time anyway. Here it is saying remove eBGP multihop before configuring TTL-security, so it won't let us. So let's remove it. And now let's issue again the TTL-security command. Let's see what's happening in the packet capture. So this is from router 1 when I removed the eBGP multihop. And this is when I have applied the TTL-security. The time to live became 255. Now, what we can see is that router 3 is continuously retransmitting its packets. This is because router 1 is not responding to, or rather acknowledging the packets received from router 3. This is likely due to the TTL value of the BGP packets received being lower than the expected value by TTL-security. Here we can see that the adjacency just went down. There's a notification message. It says that the hold timer has expired. This is because all packets from router 3 had been discarded. Now the minimum acceptable TTL value should be higher than 255 minus 2, which is 253. So this means that the minimum acceptable TTL is 254. Now let's jump into router 3 and let's configure the TTL value for 255. So here, multi-hop, we set the TTL value to 255 and let's commit this change. Okay, it was committed. Now, if we get back to router 1, we can see that the BGP adjacency immediately came up. Let's check the packet capture. If we look at router 3's packets, they have a time to live of 254. This is because when they got sent from router 3, they had a value of 255. When they arrived at router 2, this value got decreased by 1 and was sent with a value of 254. Now let's get back to router 3 and let's decrease the TTL value by 1. Let's make it 254. So now let's commit this. Okay, it is committed. Let's see what's happening in the packet capture. Now, the packets should arrive at router 1 with a value of 253. So let's see. They are still at 254. It hasn't changed yet. Let's wait for the next packet. Okay, here it comes. So here is the packet with the value of 253. We can see that router 1 isn't responding and router 3 is retransmitting the packets again. This is because the packets are getting discarded at router 1. So the minimum acceptable value is 254. Anything below that will be immediately discarded. By using TTL-security, we can protect our router's CPU against TCP attacks coming from outside of a defined hop range. To configure TTL-security, we specify a neighbor, then we add the two keywords TTL-security hops, and we specify the maximum number of hops the neighbor could be away from the local router. When we are using TTL security, the disabled connected check is no longer required. Also, you cannot have eBGP multihop and TTL security at the same time. So here we are at the end of this lesson. The important takeaways are eBGP multihop is disabled by default because the TTL value of BGP messages is set to 1. This TTL value can be configured by setting a value higher than 1. We enable BGP multihop. And TTL security is a feature meant to protect the CPU against control plane attacks by restricting the scope of BGP messages that can reach the CPU. Thanks for watching and see you on next lab.